from the Great Plains. It's a real privilege to talk to you about the use of oxalic acid to reduce Varroa populations. It's something that I spent 3 years of my life working on, and it's something that I'm just delighted that Brushy Mountain has taken the initiative to register, because there's a lot of work and expense to get a product registered where they can distribute it to you, and I'll say more about that later. I'll give you a little bit of the structure of what I'm going to talk about. I'm going to talk first a little about Varroa biology. It's not enough to know how to mix up a solution and squirt it on the bees. There's some biology of Varroa that you have to understand to effectively control it. I'm going to talk briefly about detection methods and how you make decisions about whether you need to treat or not at a given point in time. We'll talk about when to treat, how to apply oxalic acid, safety considerations, and then open it up for your questions. Daniel, I've got a little icon on my desktop. Can I move that off so it's not distracting? No. Let me try.
Sorry, Marion. There was a lot of questions because
there. I got it. We're fine.
Okay.
It's gone now. Okay, the Varroa mite, appropriately named Varroa destructor because of its being such a damaging critter, was first detected in the U.S. in 1987. It's an obligate parasite of honeybees. That means it can't feed on bumblebees or wasps or yellow jackets or leafcutter bees. It only can feed and reproduce on honeybees. It feeds on both adult and brood bees. It's caused a lot of loss in the feral bee population and an incredible amount of injury to manage bees. It's a relatively large parasite compared to the size of its host. And if you care about bees as much as I do, it was really disheartening the first time I saw this. The thing that's difficult about Varroa is that most host-parasite relationships are two not closely related organisms, like a tick on a cow. You've got a mammal and an arthropod. But since Varroa is closely related to bees, it makes it a challenge to find ways to suppress Varroa that don't injure the host because of their being close relatives. So it's an especially difficult problem, and why we need to find creative solutions to address it. When the population gets high enough, this is what you see: deformed bees that are emerging that are no longer capable of contributing to colony life. It's not common that you see a mite on a bee like you see on this bee in the center of the screen. I want you to look at this picture and tell me how many, or think about how many mites you can see. Just take a minute and look at it and count the mites. Well, I'm sure there's some of you that didn't see any. There are actually some mites on these bees. In fact, there's 1.3 mites per bee. In other words, every bee has an average of 1 1/3 mite on it, and they're that difficult for you to see. So just looking at your bees is not going to help you make a decision about what's going on with Varroa. You're more likely to see bees that have deformed wings that's caused by a virus that's vectored by Varroa. But again, looking at adult bees is not a great way to determine what's going on with your bees. And the reason is that Varroa spends a large part of its life cycle in its phoretic stage, or stage when it's on adult bees, tucked up under the sclerites under the underside of the abdomen. The bee has an exoskeleton, but it's not a solid, continuous exoskeleton. It's hard plates connected by flexible membranes. And the Varroa prides between the second and third sclerite, pokes a hole in that flexible membrane to feed. So it's not readily visible unless you roll the bees over and carefully examine them. The life cycle of Varroa, which infests both workers and drone bees, is that the Varroa will enter a cell right about the time that it's being sealed. They will lay an egg and then feed for 60 hours and then lay another egg every 30 hours. The Drone brood, they have the same pattern. They'll lay an egg and feed for 30 hours, lay an egg, and then every 30 hours lay subsequent eggs. The first egg will normally be a male, and the subsequent eggs will be females. The females that you're familiar with are reddish brown and large and readily seen. The males are teneral. They never get a hardened exoskeleton like the females because they only live in the brood cell. When the brood emerges, they die. If you look at the development time for worker bees, which is 21 days, you can see that they can dependably mature one offspring, frequently two, and almost never three. The drone brood, on the other hand, which has a longer development time, allows Varroa to reproduce more offspring. And this graph is critical to understanding Varroa because it's a prosperity disease. In other words, with a lot of the things you've dealt with, like American foul brood, European foul brood, you see colonies that will go down over time and become weak, and ultimately some of them perish. With Varroa, it builds up when bees are really prosperous, when they're collecting lots of pollen and nectar, rearing a lot of drone brood. That's when the number of Varroa in the colony zoom up. And you have a phenomena of when those populations get high enough of that colony falling off the cliff. This is an apiary that actually belonged to me in 1991 when Varroa first got into the bees. This was taken in July, and all those supers aren't full, but most of them are. So you go out and look at an apiary like that and think, wow, I'm doing good, times are good. This is what that same apiary looked like in the middle of September. The image on the right of this slide shows you all that was left of that colony that produced 80, 90 pounds of surplus honey. This is the most important chart for you to understand to deal with Varroa. If you look at the chart, the bee images show you what happens with the bee population. They come out of winter. As the spring develops, they grow, and then in midsummer they peak and start to go down in population. I want you to think of those bees as larvae because I'm talking about brood, not necessarily adult bees. At the same time, the mite population comes out of winter and begins to grow, but as you can see, the worker population or the brood population is outgrowing the mite population. But in my state, in about mid-August, the bees are reducing the amount of brood they have, and all the mites from the large amount of brood are emerging, and they have a smaller amount of brood to invade. So as a consequence, the Varroa become very concentrated in that cycle of brood that would be your winter bees. And shortly after that, colonies crash. So you can have colonies that have lots of bees and honey on them in July, and in mid-September they're crashing. So this is why you have to monitor your colonies to know when the bees need your help. So to do that, you need to know how to detect and assess mite populations. You need to know how to suppress those mite populations if you find them. You need to know when mite population suppression is needed, and you have to know something about the other factors that stress colonies and deal with them if need be. There's a number of ways to detect Varroa. I'm going to talk about two methods, one for dead colonies and one for live colonies. Dead colony assessment is best done by examining the combs from the middle of the brood nest for Varroa feces. Varroa enter the cell and feed and defecate on the upper surface of the brood cell. So when you're looking at that surface, you want to hold the frame with your top bar towards you, the bottom bar away from you, light coming over your shoulder, and look down into the top of those cells. And if you see the white amorphous feces, that's a clear indication that that colony was severely affected by Varroa. When there's just a little, they'll keep up with cleaning it up, but when they become weak to the point that they perish, there's a lot left behind. So if you have a dead colony and you wonder if it's Varroa that took them out, that's a simple thing you can do in the bee yard to test for it. The other method that I use to assess live bee mite issues is called the powdered sugar roll. It was developed by student in my lab named Paula Macedo who was trying to recover Varroa mites to use for her research. And rather than opening cells and picking mites off one by one with a brush, she found she could put adult bees in a jar, sprinkle powdered sugar on them, roll that jar around, invert it, and shake out the mites. And so a quick and easy way for her to recover mites, but it also has turned out to be a convenient way that you in the bee yard can check your bees for Varroa. I particularly like this method because, as you can see, there are mites laying on their back, kicking their legs, and really suffering, and it really makes me feel good to see that. So this is a way that you can assess your mite population. When you collect the bees in the jar and roll them around, you want to let it sit for a minute before you invert the jar. That's because the bees tumbling in the jar generate heat, and both the dust and the heat cause mites to fall from the bees. Okay, so if you're using that method, and there are other more sensitive methods, but I like this method because it's perfectly adequate for you to use to make a decision about treat me now or treat me later. For all practical purposes, all of our bees have Varroa, and when they get into the range of being a problem, you have to address it. But you can't or don't want to go treating for Varroa more often than you need to, because that's a stress on the bees too. So in my environment, we're relatively short honey producing and brood rearing period compared to North Carolina. You want to reduce the mite populations anytime you detect them with the sugar roll technique in the spring. That's because it's going to be a long time until the honey's off of those bees and you can treat them. And as you'll see in subsequent slides, the population can build up to damaging levels if you're not addressing that. You want to sample again in mid-August. Bees rarely die of Varroa, in my environment at least, until mid-August to mid-October. That's the window in which they crash. So if you sample again in mid-August and detect 3 or more mites per 100 bees, that'd be 9 mites on a 300 bee sample. You need to get the crop removed quickly and suppress mite populations so the bees have an opportunity to rear healthy bees going into winter. If you detect less than 3 mites per 100 bees in mid-August, you can delay suppression methods until colonies are broodless. There are other sampling methods that you can use, but I'm personally like the sugar roll technique because you can do it in the bee yard, you're not killing any bees, and there's an extension publication available from the University of Nebraska about how to use that technique if you'd like to request it. They'd be glad to send you a copy. Okay, so the other things you need to know is about the growth rate of Varroa in your colonies so that you can determine where you're going to be at 3 months down the road with Varroa if you find them in your colonies. So you need to know about the intrinsic growth rate. That means if we put the bees out on an island where there are no other bees around, how fast would the Varroa population grow in those colonies? We need to discuss the issue of invasion pressure. You can pick up hundreds or even thousands of mites in a day when colonies around you are crashing with Varroa if your bees rob them out. We can talk about that there is some innate resistance in bee populations and what people are doing with that. Foraging conditions. The more prosperous the bees are, the more rapidly the Varroa builds up. So in a poor year, where you're not making much honey and the bees aren't doing well, Varroa is not going to build up as fast. And temperature and humidity. The Varroa can't tolerate temperatures as hot as honeybees can, and dry, arid conditions are hard on them too. The intrinsic growth rates, you can have up to a 12-fold increase per year, which would be 0.02 increase daily when drone brood is present. And when drone brood is present, the Varroa population in a hive can double in 1 month. And when the Varroa population in a hive exceeds 1,000 mites, colonies can collapse. This is using models developed by Stephen Martin in England, but they apply as well for here. And associated diseases can alter Varroa populations required to injure a colony. So if you look at this chart, we're talking about the initial mite numbers and subsequent mite population growth. If you start out with a population of 10 mites, which is what the green line is, you can see that in 140 in the course of the time frame shown here, they don't reach the threshold of 1,000 mites, which is your treatment threshold. The red line, the yellow line is if you start with an initial population of 100 mites, and you can see that about 120 days you're going to be approaching the treatment threshold. And the red line shows what happens if you start out with an initial population of 200 mites. So Varroa, as you can see, can build up fairly quickly if they have a good foundation of founding number of mites in the colony. Now let's look at the effect of invasion pressure and subsequent mite population growth. Again, our lines are starting out with 10 mites is green, 100 is yellow, and 250 is red. Where the arrow is if we have an invasion, and excuse me, I got ahead of myself. The lines represent the intrinsic growth rate, and where the arrow is represents invasion by Varroa. Green line is invasion by 10 mites, yellow by 100, and red by 250. So you can see what a profound effect that has on how long it's going to take to reach that 1,000 mite treatment threshold. And then there's the effect of treatment on Varroa growth. The green line shows what happens if you use a treatment that's 99% effective. The red line, 80% effective, yellow, 90% effective. So you can see that those factors all play into how quickly you can go from one level of Varroa to another. Oxalic acid registration status is that it was recently approved in the U.S., the registrants, the USDA, the distributor Brushy Mountain, and they have to do a state-by-state registration in order to make it available in your state. It is available now in a lot of states. I'm not sure just where we're at. Maybe during the discussion we can bring that up. It's been used in Europe for over 20 years with no indication of resistance, and it's been used in Canada since 2010 with no indication of resistance. Oxalic acid is a colorless crystalline material. It's soluble in water, which means that if you're not going to have residues of it in beeswax like we do with some of the other products that have been used to control Varroa. It has a low volatility, and it sublimates when heated at 315 to 372 Fahrenheit. Sublimates means it goes directly from a solid to a gas without passing through a liquid stage. Oxalic acid is a common material in plants and insects. It serves the role of being a defensive chemical in the plant world, and it causes insects that try to feed on it not to want to feed on it. Plants that we consume in our diet that have oxalic acid include rhubarb, broccoli, turnips, kale, radishes, and even chocolate has oxalic acid in it. It's also a predator repellent for some insects, the box elder bug. I'll tell you about that when I show something later. And some of the vegetables that we eat contain between 300 and 17,000 milligrams per kilogram of oxalic acid, which basically tells you that the fact that there's a small amount of oxalic acid naturally in honey, and if you had a little bit in it, it's not a material that your consumers are going to be concerned with. It's something I feel like I'm comfortable treating my bees with and then feeding the honey to my grandchildren. I didn't feel that way about some of the things that we were using as desperation measures before we got to the point we are today. These are box elder bugs. If you ever see a cat eat one, they'll spit it out, and that's because it exudes oxalic acid between its legs joints that cause the material to be unpleasant. And then the fruits and vegetables we eat that have oxalic acid. Rhubarb's an interesting one. We eat the stalks in the spring when they're new and fresh, but when it gets hot in the summer, we don't. And the reason is that there's always oxalic acid in the leaves, but it moves down into the stems in the hot days of summer and makes it bitter. So oxalic acid is something that we consume on a daily basis. It's a natural constituent of honey. Many vegetables contain much more oxalic acid than honey does. There's a low risk of residues in honey, and it's hydrophilic, so you don't have residues in beeswax. If you had residues of it, they'd be in the honey. Applicator and product safety risk are minimal. Some of the things that we've used in the past to control Varroa were very closely related to things that were used in Nazi Germany to exterminate people. So this is a huge step forward to have things that are not a concern for human health and are safe for the applicator. When you use oxalic acid according to the European and Canadian recommendations, there's never been a case of residue problems in Hive products. And this is my plug for Brushy Mountain. I'm just delighted with what they've done with making this available to you. And I'm going to show you what their kits contain. This is the material, oxalic acid, packaged in 35-gram packets. It's the type of material that you would, or the amount of material that you would add to 1 liter of water to make the trickle treatment solution. If you're using the fumigator, you'd use 1 gram per brood chamber. We'll talk about that later. They sell it both as individual packets for $5.95, and they sell a kit that has both the oxalic acid, has all the oxalic acid, a syringe, protective nitrile gloves, and glasses to protect your eyes. So you can get everything you need in that kit to safely apply it. This is the label that comes with the product. It's very well crafted. You need to sit down and read it. It's not that much reading material, but there are some safety things that you need to be aware of. You can injure yourself with this material if you're not careful. By the same token, you can injure yourself with the acid in the battery in your car. If you open the caps and take a big whiff, it will do a lot of harm to you. So I'm not saying it's not perfectly safe to use, it's just that you have to be responsible and know what the safety concerns are. It can be applied by trickling or evaporating. Trickling is the preferred method in Europe and Canada, and effectiveness is greater than 90%. Some of the studies have been done when there was still some brood in the colony, and my studies with colonies that we checked to make sure they were broodless, the control was better than 98%. The mechanisms of acrocidal action are not fully known. There's a lot of speculation, but we really don't know why it works. So for trickling, you can prepare the solution by dissolving 35 grams of oxalic acid in a liter of lukewarm sugar water. That sugar water should be a 1-to-1 solution. That means 1-to-1 by weight. So if you use 4 pounds of sugar, you ought to use 4 pounds of water. It's helpful to know that there's 8 pounds of water in a gallon. So if you're using a gallon to make sugar syrup, you want to add 8 pounds of sugar to make a 1-to-1 solution. If you make a more concentrated solution, it makes the bees want to consume it. You don't want them to consume the syrup. The purpose of the syrup is to make it sticky so it adheres to the bee's body, and we'll talk about that a little more in a minute. If you make a water solution of oxalic, it'll just bead off and won't work. So use a 1-to-1 by weight solution of sugar water, 35 grams in a liter of it. That's enough to treat 20 colonies. You want to treat in the autumn or early spring when little or no brood is present, or you can artificially create a break in the brood cycle for treating, and we'll talk about that. It's going to be most effective in broodless colonies because it does not kill mites that are in brood cells. It only kills phoretic mites that are on adult bees. You want to treat when the temperature is between 35 and 55 Fahrenheit. You want the bees to be in a loose cluster. You want all the bees in the hive, but you don't want a tight cluster because then you don't get the distribution of the material that you need. Wearing protective equipment. If you need to create an artificial break in the brood cycle, here's how you can do it. If you look at the row of numbers, that's days of development. On day 1, which if you look at the 1 inside the white arrow, you can cage the queen. On day 14, release the queen, and on day 21, treat. That will give you a colony that is essentially devoid of sealed brood. At the time you're treating, it'll have eggs and larvae. The one thing that you need to do if you use this method is on day 4 and day 8, you need to open the colony and check for queen cells, because when you cage the queen, she can't lay. Some of those colonies will start queen cells. So it's a bit of work, but if you want to treat at a time of year when there's normally brood in the colony, it's a way you can do it. Another way you can do it would be involving a queen cell. And if you've ever read Gene Killian's book, Honey in the Comb, this is similar to the method he uses to produce comb honey, because it essentially frees up the adult population to store honey because they have that break in the brood cycle right when the honey flow starts. So if you're using this method on day 1, you want to remove the queen, cut queen cells out on day 4 and day 8. On day 8, you would insert a ripe queen cell and then treat on day 21. If you insert that queen cell on day 8, when the queen emerges, it'll be 5 to 7 days before she mates, another 5 to 7 days before she lays eggs. So that gives you that break in the brood cycle. Some treatment considerations. You want to mix oxalic acid fresh. If you mix it up and let it sit around for a week, you're going to get a material called hydroxymethylfurfural formed in it that causes bees to have dysentery. So mix it fresh. It's not an expensive material. Mix up what you can use in a day or two, and then if you need, discard that and make a fresh solution, but don't let it sit around for any length of time. You do not want to treat weak and starving colonies. Again, if you treat with the trickle treatment and come back in a week, if you spilled oxalic acid on the top bars, those little beads of it will still be there. The purpose of the sugar is, again, to make it sticky and make it adhere to the bees. You don't want them to consume it. If you feed weak or starving colonies, they'll consume it. Do not use thick syrup. Use 1-to-1. If you use a highly concentrated syrup, the bees will sometimes consume it. The sweetness appeal exceeds the bitterness of the acidity. And so you want to always use 1-to-1 syrup. Treatments when brood are present is ineffective. In my case, we treated bees 3 times at 1-week interval in July, and at the end of the treatment period, couldn't tell any difference in those and the controls. You've only got 15 to 20% of your mites on adult bees in July, and so you're just not going to have an easy time getting ahead of things that time of year. Treat when the temperatures are above freezing and below 55. Don't mix and store the product for more than a week, and do not treat when honey supers are in place. So here's a pail that has the material in it. You've got a 50 milliliter syringe that you're sucking it up, and you're trickling 5 to 6 mils between the occupied frame spaces. You can practice by getting a syringe and water and running it back and forth until you evenly distribute the material and get 5 to 6 mils per frame space. Sometimes you can do this if your bees are in a single story colony. It's easy. If they're in multiple brood chamber colonies, sometimes you'll have to break the brood chamber apart to get to the bottom box to treat. Bob Cox and I did studies where we treated lots of colonies with oxalic acid, and we timed ourselves and we averaged 1.5 minutes per colony to apply. So even if you have a lot of bees to treat, it's not that time consuming. How much of the solution should you apply? If you're treating 5-frame nuclei, 30 mils, single-story colonies, 40 mils, double-story colonies, 50 mils. You can also apply oxalic acid by vaporization. This is a vaporizer that has a chamber that you put the material in. It has electrical connections that you hook to a 12-volt battery, and it sublimates the material and fumes up into the colony. If you're going to do this, you want to use 1 gram for singles and 2 grams for double. If you don't have a gram scale, 1/4 teaspoon is about 1 gram. 1/2 teaspoon would be 2 grams. You want to seal the entrances while treating and leave them sealed for 15 minutes post-treatment. You want to allow 2.5 minutes for the treatment to evaporate, and then be sure to disconnect the power after that time. You need to then remove your evaporator, let it cool a little bit, and then you can do final cooling by dipping it in a pail of water. That'll get any unsublimated material off. And you want to make sure that it's thoroughly cool before you add new material, because if you bring it out and it's hot, add new material to it, it will sublimate right at your face. So be very careful and make sure it's cool before reloading. This is just reloading the material with a measured amount. If you have a 3/4 inch depth bottom board, then you may well be able to slide the applicator directly in. I use bottoms that are 3/8 of an inch depth, and they don't go in so well. So you may have to, in the case of a 3/4 inch bottom, you may have to lift them up and cut off the bridges and ladders bees have built so that the applicator slides in and out easily. If you have 3/8 inch entrances, you may need to make a rim like the one shown here to put the hive on for the treatment period. Oxalic acid vaporizations. Apply it only to outdoor colonies. Treat when they're broodless if you can, or make them artificially broodless. Treat when temperatures are 35 to 50 Fahrenheit. Use goggles, nitrile gloves, and respiratory protection. Have a friend assist you. Beekeeping's more fun with a buddy, and when you're going out to do these treatments, have someone go with you. And then monitor your success by checking the bees before you treat and after with the sugar roll technique to know how you've done. You can also treat package bees. That's a condition in which there is no brood and the treatments are going to be highly effective. You can either treat them yourself on the receiving end, or the shipper can treat the bees before they're shipped to you. If you're ordering packages, be sure and ask the shipper if they have treated them, because you wouldn't want to turn around and treat them again 3 or 4 days later after you get them. So you want to ensure that the bees are clustered in the package cage. 2 hours before you treat them, you want to spray them with 1:1 sugar water, because when you treat them, you want their belly full so they don't try to consume the syrup. So they just get it on their body and it's sticky. You want to treat them with 3 milliliters of solution per 1,000 bees. And it's helpful to know that there's 3,500 bees per pound, or 7,000 bees in a 2-pound package, 10,500 in a 3-pound package. So that would be 21 mils of solution, or 31 mils for a 3-pound. After they've been treated, ideally they'd be stored in a dark, cool room before hiving. If you have gotten packaged bees through the mail and they've been in the mail several days, the last thing you want to do is hold them for 3 more days. I would install them, come back in a week, and treat them after they're installed rather than trying to treat them in the package. and hold them before you hive them. So there's an applicator being used to spray the bees with the treated solution, and then holding them in a cool, dark place for 72 hours. Okay, it's important to understand how oxalic acid is distributed in the colony. Treated syrup is not consumed intentionally, and treated syrup spilled on top bars will be untouched the next day. The purpose of the syrup is to make the solution sticky, and if you apply it in water, it beads off and is ineffective. This is some research that we did to figure out just how oxalic acid is distributed in the colony. We made up colonies that were divided in the middle, that had colony on each side, and we had three types of dividers. We had a solid one, which would allow no bee contact, no vapors, no exchange with the other colony. We had a double screen, which would allow the bees to not touch each other, but that it would allow freely vapors to move from side to side. And we used a queen excluder divider, which allowed the bees to physically move from one side to the other. So we established nukes in both sides, treated the nuke on one side, and then looked at what happened for mite fall on both the treated side and the untreated side. And what we found was that with the solid divider, the treatment of one side had no effect on mite fall on the other side. With the double screen, the treatment on one side had no effect on mite fall on the other side. But with the excluder, where bees could physically move through the excluder from unit to unit, we had significantly higher mite fall on the untreated side. So this basically demonstrates that the physical contact is how the material is spread. It's not spread through trophallaxis, because with the double screen, the screens were close enough that the bees didn't walk on each other, but they could feed each other through the double screens. So we found no evidence that consuming treated hemolymph affected mite fall. What we did find is physical contact with the material did. Well, you want to also think about resistance management, and to me that's one of the beauties of oxalic acid. It's something you can go in the fall each year and treat the bees with it and really clean out the mites, so you start out the next year with very few mites. It has its limitations, because if you have a mite problem in August, you're not going, lots of brood in the colony, you're not going to get great effect with oxalic acid. You may have to use an alternate material to get the bees to have a healthy hatch of brood going into the winter. But using oxalic acid in late November to clean up mite populations will also be valuable in resistance management, because it will kill any mites that may be resistant to any other mite suppression methods that you've used. Applicator safety is just mostly common sense, but you don't want to breathe dust or fumes, particularly if you use the vaporizer. You want to be very careful not to breathe fumes. Do not get it in your eyes or skin. Wear protective eyewear. Wear respiratory protection. You want to have water available to rinse it if you spill it on yourself in any way, and wash your hands after handling. You should launder clothing separately, wash your hands before eating, drinking, chewing gum, using tobacco, using the toilet. And it's always, when you're doing any kind of treatment, prudent to take an assistant with you. Personal protective equipment, you just wear long sleeve shorts and pants, shoes and socks. Hope none of you go out barefoot to keep bees. Chemical resistant gloves, protective eyewear, and a respiratory cartridge to protect your lungs. First aid, if you're crazy enough to drink it, you call a doctor immediately. Have a person slip water. Don't induce vomiting, because it will burn coming up just like it burns going down. You want to dilute it. If you get it on the skin or clothing, remove that contaminated clothing and rinse it by pouring water over it and call a doctor or poison center for advice. So these are exposures that shouldn't happen, but if they for some reason did, this is how you deal with them. If someone were to inhale the fumes of the vaporizer, move them to fresh air, you don't want to give them mouth-to-mouth artificial respiration because you could expose yourself to it. If it's in the eyes, flush the eyes, and common sense stuff. Okay, I'm going to skip these and take your questions. I use this for my final slide when I talk about oxalic acid because I'm a beekeeper. I love bees and I love honey. I love eating it and I love giving it to people. And I like feeling good about it. And the oxalic acid is a tool to help you control Varroa. It doesn't have the baggage that a lot of the things that we had to use because we had no other alternatives when we first started finding Varroa. But it's not going to leave residues in beeswax. It's going to, if it has residues in honey, they're going to be acceptable, not higher than is found in other food products that we normally consume. And it's safe to use, so I'm really delighted to talk to you about it. I'm delighted that Brushy Mountain has registered it and is distributing it.